Okay, so today is a review day. Tomorrow we are taking a test on this. I know I didn't really announce it yesterday, or last week, I mean, but I'm looking at what we have to do, looking at the way the days are working out, because Friday we don't have class because of the revival day thing. So I don't like giving a test on Wednesday just because it's a little bit shorter. It's only like 5 minutes shorter, isn't it? 5 to 7. Is it 10? It's not 15. I don't think it's 15. It's no more than 10. Is it 10? Okay. Well, still, anyway, it's shorter. I want to give you the most time possible. So that's why I decided to give you the test tomorrow, because you can do the test tomorrow, corrections on Wednesday, and then Thursday we'll do another lesson. We haven't finished the chapter yet. We still have to do 6-8, and I am going to do it. It's just not going to be, I'm not even going to put it on a quiz or a test. I'm just going to do it just to teach it to you. It's graphing. All right. Normally I would put it on the test, but just the way that this week worked out, I just figured we would do it that way. Is that all right? All right, so you have some questions on 6-7, correct? And we have not had a quiz on 6-7, but that's the stuff that we're doing right now, that we're going to go over right now, will be on the test, okay? So you will see that kind of stuff on the test. So let's do one or two, and then we'll go look at the old quizzes and use that as our review for the test. All right, so which ones do you have? What numbers? 29 and 31.
Is 29 the one where one of the answers is 0?
No, because you're writing a polynomial function. Well, I mean, one of the zeros is 0.
Yeah.
Because they give it to you. All right, well, let's do it. All right, let's write it down. So this is what, 29? Mm-hmm. Oops, forgot to do this. There we go. All right, so number 29. So they give you the zeros, and you have to write the polynomial function. So they give you 0, they give you -1/2, and they give you 8. Is that correct? It is. All right. So what are we going to do here? You know what to do with the 8, right? Do you remember on this? In order to get the 0, let's say x is equal to 8. That's one of my answers, correct? Right? What was the step before this? Like if you actually had a polynomial and you had to solve for x, you had a step right before you solved for x. What was that step? It was x, what? -8 equals 0, correct? So that's kind of what we're doing. We're kind of working backwards from the answer. So one of our factors, I guess if you want to call it, is x -8. Let's do this one. What do we have here? X, what?
2x.
Well, x equals -1/2, correct? All right, so you could do it like this. You could do it a couple ways. This, I don't know if this makes more sense or not. You can multiply both sides by 2, correct? Which will give you 2x equals what? -1. And then you could do what? Add a 1 to both sides. Would you agree? So if I was to actually solve for x or find the zeros of the function, this is what one of my answers would look like. But then what would I have to do? I have to solve for x. Does that make sense? So it would be nice if we just wrote it, what? 2x plus 1. You could write x plus 1/2, right? Couldn't you? Right? And that would work. But it's a lot easier, I think, to not have that half and to write it like this. So that was a little tricky. What about the 0? So what did we say? X is equal to what? Yeah, it would just be x equals 0. So it would be like x, this is kind of silly, but what would you do to this number? Subtract it or add it to the other side. It really doesn't matter, right? Equals 0. Isn't that dumb to even do that? All right, but it's basically what? Just x equals 0, or what would this be? That would just be an x, right? Again, remember doing the work, right? Solving for x, and sometimes you get something that looks like this. And so what did you end up doing? You set it equal to 0, so you write what? X equals 0. There it is. Okay, 2x plus 1 equals 0. And then x minus 8 equals 0. Does that make sense? All right, so this is how we would set that up. So it's a little different than some of the other ones that you had to do, especially I think with the fraction. Did they give you any fractions on any of the other? Or is that the only time they ask you to solve for the zeros? It is. Yeah, because they give you the polynomial every single time, or the function. Yeah, these are the only problems where they actually give you the zeros and you have to write the polynomial function. But this is what that is. And now, what do we do with all this right here? It's not my answer. We multiply them all together, okay? So let's just multiply these together. So let's just get rid of this. Give me some room here. So let's multiply them together. What I would do, I would multiply by that x at the very, very end. Okay? What I would do is just do the FOIL method with these two. Then once you get that answer, then I would take that answer and multiply it by x. Okay? So keep that right there. So what's this going to be? Let's do it. 2x times x is 2x squared, and then minus 16x. Do you see that? 2x times negative 8. Then the inside is plus x. The outside is minus 8. Let's simplify it before we multiply everything by an x. So it's what? 2x squared minus 15x minus 8. Correct? Okay, and now we could see we multiplied these two things together. Now we're just going to take it and multiply it by an x. So what do we get? 2x cubed minus 15x squared minus 8x. And that is your function. If I was to set that equal to 0, I don't think they do put it equal to 0. Nope, they just say what the function is, right? If I was to set it equal to 0 and start from that, what would I end up with? I'd end up with this as my answer, okay? Or if I just wanted to factor it, what would I end up with? I would end up with this if it just said to factor it, okay? Does that help a little bit?
Yeah.
All right. This one, the negative 1/2 was a little bit weird, all right, but it works out. And I believe if you would have kept this like x plus 1/2, this still would have worked out the same way. I just think it looks a lot nicer without having to deal with the fractions. Wouldn't you agree? Did anybody actually put an x or x plus 1/2 here instead of 2x plus 1? All right, did you still get this as an answer? Yeah, you should. All right. But I don't know. I saw that and I'm like, okay, how do you get this? Yeah, multiply by 2, add a 1. Yeah, it's that. We good? All right, and number what? 31? Okay. Let me cheat a little bit, just make sure I do it right. Okay. Now, do you remember that last thing that we talked about? I forget the names of these things all the time. The conjugate root theorems. Do you remember that one?
No.
It was the last thing that we discussed in here. I believe it was the last thing. It's that one where if I gave you this as one of the roots, then what else is one of the roots without me even having to tell you? Right. Then 3 minus 2i is also one of the roots. Okay, that's the complex, what do they call it? The complex root theorem. But they also have the irrational root theorem, which is like, I don't know, 2 plus the square root of 3. If they give you this as one of your zeros, or one of your, I guess you could call it a 0, sure. Then what would another 0 be? If that's the only thing they give you, but what's another one that you will have? 2 minus the square root of 3. All right, so you got to keep that in mind for what we're going to do on number 31. So on number 31, they give you 2 zeros, or 2 answers, okay, or 2 values for x, or 2 roots, however you want to look at it. They give you 4, and they give you negative square root of 2. All right. So what are my factors going to be? How am I going to write that? This would be what? X minus 4 is one of them. What's the other one? X. This would be minus negative square root of 2, or x plus square root of 2. Agreed? Now, if this is one of my roots or one of my zeros, what is my other zero? This is 0 minus the square root of 2, correct? Then this is an irrational, just like this is. So what's one of my other roots according to that theorem, that irrational root theorem? It's positive square root of 2. It's 0 plus square root of 2. Okay, so if they give you 0 minus square root of 2, what's another one of my roots have to be? It's got to be the conjugate of it. Remember the conjugate? That's if you change, these two are conjugates, these two are conjugates. So if they give you this, then automatically I know that's a root. Well, if they give you this, then automatically I know this is a root right here. Make sense? All right, so that was the part about that rational root theorem that you had to know. And then what else do we have? X what? Minus square root of 2. Yeah? All right. Now, we multiply. What are the two easiest ones to multiply? And there's definitely two that are easiest. Yeah, the plus or minus, exactly, because these are conjugates of each other. Remember, the outside and inside go to 0, right? So all I got to do is multiply the first and the last. So I'm going to keep that x minus 4 right where it is. Don't forget it, because we still have to multiply by it. And then what's this going to be? X squared plus and a minus multiplied is negative. And square root of 2 times square root of 2 is just 2. There we go. Everybody see that? Now, what are we going to do? Foil this thing, right? So x times x squared is x cubed minus 2x minus 4x squared plus 8. Do you agree? Am I going to circle that? I mean, I would give that to you, but what would look a lot better? X cubed. And what would I put next? Yeah, minus 4x squared. All right, go in descending order, right? Highest power down to lowest. And then minus 2x. And then, whoops, forgot the x. 2x. And then plus 8. So that would look a lot better. Is that the answer they gave you? Yep. And they write it exactly like that too. Once you know how to do those, they're not really that difficult. Okay, remembering to put that other, if this right here, they give you that as a root, remembering to put that was pretty important. Why didn't we, I erased it. Why didn't we do that on the other one? Why didn't we stick an extra one on there for that? Because there was no irrational number and there was no complex number involved, right? If there's no complex and there's no irrational, then you don't have to stick an extra one in there. But if they give you one irrational, you know there's another irrational. Okay, it's conjugate. If they give you one complex, you know there's another complex number. It's its conjugate. Make sense? Okay. What about one of the other ones where you actually had to solve the equation? They gave you an equation. Let's do one of them. Pick one of them. Like up to 26. Any 21? 25? All right, let's do 25. Yeah, because you're going to have a complex in there. So we might as well do that. I'm just going to get rid of this. All right, so 25. X to the fourth minus 4x cubed. X to the fourth minus 4x cubed. Minus x squared minus 16x. It's x squared minus 16x. Then minus 20 equals 0. Minus 20 equals 0. Again, let me cheat a little bit just to make sure that I don't take too long on this because So there's no way that I could group these. There's nothing like right here. I can't like group that and factor that. There's nothing in common with everything. So what do I have to do then? I got to go to that, whatever they call that thing, where you find the possible roots. Remember that? The P and the Q. Rational, what do they call that? Rational root theorem or something like that? Yeah. There's all these theorems. I can't even remember them all. Okay. But there's like one called the factor theorem, rational root theorem, and then there's another one. I don't know what it's called. Remainder theorem. Very good. Okay. We're actually going to use a combination of all three of those to be able to do this. All right. So that's what we're doing. You could do the whole P and Q thing. since I have the answers right in front of me, okay, I'm just going to give you a shortcut. Is that all right? On a quiz or a test, you're going to have to put in all the numbers and see what works, all right? So what numbers are we putting in? This is a 1, so I don't really have to worry about the Q. So what do I got? Plus or minus, what, 1, 2, what, 4, 5, and 10. That's it. And 20, right? Now, there is one that's going to take you a while to find, all right? And, well, actually, you know what? We could, yeah. Well, you could try positive 1. It's not going to work. Try negative 1. Negative 1 works. What do I mean by that when I say negative 1 works? Let's just do that since I cheated, right? I looked, and negative, I'm sorry, it's actually, yeah, negative 1. So negative 1 actually works. So let's put a negative 1 in there. So I'm going to go f of negative 1. What do I mean by it works? It means if I put a negative 1 in for all this, it actually comes out to equal 0. All right? So negative, can we do this in our head? Negative 1 to the 4th is 1 minus this negative 1 cubed is negative 1 times negative 4 is plus 4. This is a negative 1 squared is just a 1, so that's a minus 1. This negative 1 right there, so that'd be a plus 16, and then minus 20. That's 5, that's 4, that's 20 minus 20 is 0, so that does work, okay? If it was me, I probably would have put a 1 in there first. All right, that's just how I like to do it. I like to put the 1 in there first, then the negative 1. If neither one of them work, then I try 2, then negative 2, and then 4 and negative 4, and then keep on going until I find one that works, okay? Well, the negative 1 works for this, so that's cool. So what do I need to do? I need to find, I know it's a factor, so what is my factor? X plus 1 is a factor, isn't it? All right, and a lot of times I like to actually write this down. I like to write factor. So let's find out how many times does negative 1 divide into this? Well, not negative 1, but x plus 1 divide into this. So I put a minus 1, put your coefficients. So I got a 1, a negative 4, a negative 1, a negative 16, and a negative 20. All right, let's do the math. Everybody likes this now, right? Synthetic division. Yeah. I was watching a video the other night, and this lady was teaching, and she says, okay, let's do long division on here. I'm like, what? Why would you do long division? I mean, it works. It'd be fine. But man, this is so much better. Whew. Anyway, bring that down. What do you get? Negative 1, that's negative 5. Multiplying, that's a 5. Add them up, that's a 4. Multiply negative 4, add them up, negative 20. Multiply positive 20, add them up, it's 0. So you know you're good when you end up with a 0. All right, what's my... what are all my factors now? So I've got x plus 1 times what? What's this? That's my remainder. That's my constant, my x squared, my x cubed. Or you could just look at this and say this is x to the 4th, so this must be 1 less, which is x cubed. All right? So x cubed minus 5x squared plus 4x minus 20. And there we go. So now we go through the routine again, don't we? Try some numbers. Now, the book, yep, I think that's the only one that works. Again, I would try them. Now, we already tried 1 and we tried negative 1, right? So I wouldn't start with those again. What would you start with? I would start with positive 2, negative 2, positive 4, negative 4, positive 5, negative 5, and positive 5 actually works. So you might have to do a little work with that. All right, because you're going to have to try them until you find out which one works. And 5 does work. Let's put it in there just to see. Is that all right? We're putting it into this right here. Okay? This one right here? It might. I think you're right. Let me double check. Yeah, they don't do it that way, but I think... Oh, I was looking on the wrong one. I think you're absolutely right. That's something that I should have said. Because I said at the beginning, didn't I? I said, look to see if you could group it. Look to see if there's a common factor. On this one, I believe this does work with grouping. Yeah? So let's not do it with the 5. Yeah, because that's a lot of work, right? Trying all those different numbers. I mean, it will work, but I think this is probably more efficient. So let's put the x plus 1 right here. And let's do this. What are we going to do? Group this and group this. Yeah, let's see if it works. All right, I'm going to get rid of those parentheses, kind of made a mess. What can we do here? Factor out an x squared, correct? So I get x minus 5 plus factor out a 4, and I get what? X minus 5. Very good. Good call. That saves us quite a bit of work. All right, so factor by grouping is a great way to do it if you can do it that way. You can't always do it that way, but on this you can. So what can I factor out here? An x minus 5. What's left over if I factor out an x minus 5? An x squared plus 4. There we go. Good call. All right, and we set all the stuff equal to 0. I just haven't been putting that down. And then we solve for x. So x equals what? -1. X equals 5. What about this? X squared plus 4 equals 0. Subtract a 4 from both sides. So that's -4. Square root, and that x is equal to what? 2i. Very good. But it's plus or minus, don't forget that, sorry. And there's your 4 answers. It was an x to the 4th problem, wasn't it? All right, so there's your 4 answers, -1, 5, plus or minus 2i. Do you understand why the conjugate thing works? Because if you get one of them to be a 2i, what's the other one have to be? A -2i. You see that? So that's why that conjugate thing works. Because positive 2i and negative 2i are conjugates of each other. If one's a factor, the other one has to be a factor. I watched, again, another video on this, and this guy says, every single time it is always with the conjugate thing. He says, so you're always, if you get a positive 2i, you're always going to have a negative 2i with it. All right? He was very adamant about it. So there you go, and that's your answer. Bang, bang, and bang. Yeah, that was nice right here to understand that does, and I should have looked at it. I looked at it at the first one, and I didn't think about it for this one. All right, so good to go. Everybody okay with that? All right. That pretty much covers that whole lesson, right? What we just did right there? Yeah. All right, let's go to this. I don't know if we'll have, yeah, let's turn that in. That's 6, 7, right? It wasn't A or B, right? It was just straight up 6, 7? Yes, that'd be good. Yeah, we'll do 6, 8 when we finish the test. I wanted to include it in there, but just the way the days worked out, it just didn't work out that well. All right. Let me get my quizzes out. I think I got them in my folder. Algebra 2. There we go. All right, so basically study the quizzes and study the stuff we just went over. That's 6, 7. I mean, I took it from you. You okay if I have it? I mean, probably not. But you can watch the video. All right. All right, here we go. You remember this stuff? It's been a while. This stuff's important because the last lesson that we haven't gotten to yet, that we will after the test, is going to use some of this stuff. All right. But this is kind of the basic things. All right, if I give you a graph, what's the vertex? The vertex is that point right there. Where is that? 2, -3. Is it a maximum or minimum? It's minimum because it's at the bottom, right? It's the lowest number on that graph. That's a minimum. Axis of symmetry is the one that goes right down the middle. Boom, 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 boom. That right there. It's a vertical line. Vertical lines are always x equals wherever it goes through. So where is it? At 2. Okay, x equals 2. The domain are all the x values. What are all the x values? They get everything, right? Because that keeps on going. I could go on the x-axis as long as I want. I could eventually come up here and reach the graph. Same thing with going to the left. Would you agree? So every single x value is in play, all right? That's what it means. What's that? The fancy R. I haven't written any answers here, but yeah, all the real numbers Or you can just write out the words, all real numbers. That'd be fine. I wouldn't care. What about the range? The range are my y values. Look, there's nothing below this point right here. Everything is from this point where? Up. Okay, so it would be what? It would be y is greater than or equal, right? Because it equals that point. Now, where are we on the y-axis? 1, 2, 3, -3. So it's everything equal. It could be equal to -3, and everything above -3 is a valid y value for that graph. We good? All right. Now this one, they don't give you a graph, but they ask you some of the same questions. But you got to look at this and just determine from that all this kind of thing right there. What's the vertex? Do you remember this? Y equals, what was it? A times x minus, what was it? H squared plus k. All right. So where is the vertex? The vertex would be what? H k. All right. So what's the h on here? X minus what squared? X minus 0 squared, right? What's the k? There is nothing because there's nothing added to the end of it. So it's 0, what? 0, 0. How do I know if it's a maximum or minimum if I can't see the graph? You look at this thing right here, all right? It's a negative, which means it's going to go down like this, right? So where is that? Where is that vertex point right there? It's a maximum. That's the highest it can go. Everything else is below it, so it's a max. Okay? Is it steeper or flatter? Well, where do we look for that? You look right here at the A. If it's what? Greater than 1, the absolute value, okay? Not considering the negative. But if you don't consider the negative, the absolute value is what? It's greater than 1, so it's what? So it's steeper, okay? It's steeper. And I know some people say, well, -2 is less than 1. But we're looking at the absolute value of it, okay? All right, make sense? I doubt I'll have you do the 5 ordered pair things, okay? So let's not worry about that. That's all I'm going to say about that. I was going to say something else, but didn't. All right. All right, here. It says, write it in this form. So there's that vertex form that I just wrote a little earlier there, right? How do I take this and put it into that form? What do I use? Completing the square. Very good. Okay, so I use completing the square. So I've got x squared plus 12x. Now I don't have a 0 on here, do I? Plus, I'm going to leave it blank. I'm just going to take this and just push it over to the side. So what would that be? Just a plus 18. Everybody see that? And then I got to fill in this blank. How do I fill in the blank? How do I complete the square? This is completing the square. What do I do with that middle term? Yeah, put it over 2, which is 6, and I square it. 6 squared is 36, so I add a 36. Now, if I add a 36 here, remember, I'm not putting it on the other side of an equal sign. All right, it's still on the same side. So how do I still put a 36 here, but still keep this equal to what it was originally? That's right, I subtract a 36. So really, what did I do? All I did was push that 18 over, and then I added a 36, I subtracted a 36. So really, did I change the value of that at all? No, I didn't change it at all. But I did something, okay? I made this into a perfect square, okay? That's by taking half of it and squaring it and putting it here, adding it to this. That makes it into a perfect square. So what do I get? X plus what? 6, and then minus 18. So that's my function. So f of x equals that. And that's all they wanted you to do. Oh, forgot the square, didn't I? Yep, that's squared. And that's all they wanted you to do. All right? 5's kind of the same thing. I'm not going to go through that. All right? Let's keep going. Do we want to skip this and go to the next one, or do we want to just stick with this since we haven't done this in a while? It's up to you. Why is it a minus? Where? Right there? Because it's 18 minus 36. Okay? Same thing here. You're gonna do the same thing that we just did, and you're gonna graph it. So I'm just gonna save you some time. If you put it into that vertex form, you get x plus 3 squared plus 2. All right, so f of x equals this. So how would I graph this? Well, first of all, the best thing to do is to find the vertex. So what's the vertex of this? So what is it? Is it 3, 2? It's negative 3, 2. Because remember, the vertex form is x minus h. This is the same thing as x minus a negative 3. So it's negative 3, 2. So negative 3, 1, 2, 3, 1, 2, right here. And then what I would do, I would just punch a couple numbers in. Look. Well, actually, this is not steeper or flatter, is it? So if you go over 1, okay, how far do you go up? You just go up 1. If you go over 2, you go up 2 squared, because this is a quadratic, right? 2 squared, which is 4. So it would go to here. The other side is exactly the same. See that? And then there's your graph. I'm not, well, it's pretty, I'm terrible at this. That's not bad. Yeah, some of you guys laughing at me up here, and some of your graphs look terrible. And I thought, you're using a pencil and paper. That's easier than this little scribbly thing here. All right, you get the idea? All right. The other one I messed up. I'm going to try to remember when I do the test to just make sure that it all fits on the graph, okay? 8's kind of the same thing as what we did before. Let's do this. Yeah, let's not worry about 8. Let's go to 9. Find the x and y intercepts. So how do we find the y-intercept? We set x equal to 0. So we can almost do this in our head, can't we? Pretty much do it in our head. So if that's a 0, that's 0, that's 0, that's 0. So what is it? So it's the y-intercept would be what? It'd be 3, 0, right? Because the y-intercept, or I'm sorry, I was right, or you were right. It's 0, 3. The because we set x equal to 0, so that's why that's 0, and we came out, this is our y, we came up with y equals 3, so that's how you would write it there, okay? And then, how do you find the x-intercepts? Well, you set y equal to 0, so you've got negative 4x squared, negative 4x, I'm not going to do every detail on this, it takes too long. We set that equal to 0. And then, what are you going to do? You're going to solve for x, aren't you? All right, so when you solve for x, I use the quadratic formula because it doesn't factor. Okay, so I use and plus you got this out here. I'm not going to complete the square because that's a negative 4 out there. So I use quadratic formula. When you get the quadratic formula, you get negative 3 halves. Yes, so you get negative 3 halves, and you get 1 half. And of course, what did we do to the y? We made the y 0, so that's that 0. We made that 0. So use the quadratic formula. I'm just not going to go through all the details, and that's what you would get right there. Okay? All right. This is no different than the other graphing thing. First of all, we're going to take this, put it into that vertex form, and you would get... You do the completing the square thing. Okay, we did that once earlier. You get this, and then you get minus 2. And this is what we want to graph. Now, it says y is greater than, so you're going to have a shading. And plus, it doesn't say or equal to, so what's the line going to look like? It's going to look like a dotted line. Remember that? All right, so what do we got? Negative 3, negative 2. Right there. Is my vertex. It goes up, and instead of going up 1 over 1, it's going to go, instead of over 1 up 1, it's going to go over 1 up 2, because it's 1 squared times 2, right? So it's going to look like that. And if you go over 2, instead of going up 4, it's going to go all the way to 8. I don't know how many lines we have on here, but let's say that's 8. It goes up there, up here, like this. And now it's not going to be a solid line because it just says greater than. It doesn't say or equal to. So it's going to be like this. Now what do? We got to figure out where we're going to shade. So pick a number. Pick 0. That's definitely not going to be inside there, right? You know it's outside for sure. So let's pick 0, 0. That's an easy number to put in here. So if I put a 0, 0 in there, what do I get? There's 0. Is 0 greater than this stuff right here? Put a 0 in for this. 0 plus 3 is 3. Squared 9, 18. Minus 2 is what? 16. Is 0 greater than 16? No, it's not. So I'm not going to shade where? Outside. So I'm going to shade where? Inside. Yep, and that's how you do that. Make sense? All right, let's keep going. Here's the latest one we did. We got like 10 minutes. So I'm not going to be able to do every single one of these. So one was simple. Almost everybody got that. Long division. Synthetic division should be pretty easy now, shouldn't it? Yeah, because you do them so many times. Right, the synthetic division should be a piece of cake. And we just finished doing a bunch of these, didn't we? Or something like it. All right, which one? Yeah, they're both about the same. Let's do 3. 3 looks a little bit more intimidating, doesn't it? So x squared plus 6x minus 2. Oh, I didn't leave much room for the answer. That's okay. So this one goes inside here. So it's x cubed plus 2x squared minus 26x plus 8. I didn't have to fill in anything with zeros, did I? Oh, 26x, sorry. X plus 8. Because look, I got an x squared and x cubed, x squared, x, and a number, so I'm good as far as that. I don't have to fill in anything. I didn't have to fill in anything here as well because I got a y squared and a y, all right? So what do? Basically, I'm doing this. I'm saying x cubed divided by x squared. Okay, that's what I'm doing. I'm saying how many times does x squared divide evenly into x cubed? Well, x number of times, right? So, because x cubed divided by x squared is x. So then I put a subtraction thing here. Now I'm taking this and I'm multiplying it by that whole thing and I'm putting it here. All right, so if I multiply it by the whole thing, what am I going to get? I'm going to get x cubed plus 6x squared minus 2x. All right, let's bring everything down. Remember, we're subtracting all this. X cubed minus x cubed is 0. 2x squared minus 6x squared is negative 4x squared. And then right here, negative 26 minus a negative, which is plus, so it's negative 26 plus 2, which is 24x. Bring down the 8. And repeat the process. All right, take this and divide it by what? X squared, right there. So negative 4x squared divided by x squared is what? It's just negative 4, so we put a minus 4 right there. And then we're going to take that negative 4 and multiply it by all this and subtract. All right, so let's do that. Negative 4x squared, negative 24x, and then positive 8. This one works out nice and easy because everything cancels out, doesn't it? That's 0, that's 0, that's 0. So what's my remainder? 0. So what's my answer? It's just x minus 4. And that's it.
Wait, isn't it 48x? Because it's minus 1.
Good question. I messed up. I think this is a plus 24. Yeah, it should be plus 24. Sorry. Why did I say minus? Wait a minute. Hold on. Let me look. Oh, right here. Did I make that positive? Yeah. Yeah. This is negative 26 plus, which is negative 24. Yes. That's where I messed up. Yep. Now they add up to 0. Okay. Well, yeah, because this is a negative, right? Yeah, that's a negative 24. There you go. Now it's better. Good question. All right, anything else? Got like 7 minutes. Okay. Yeah, this is kind of what we did earlier, but we'll do it. This one's a little bit easier. We just have to factor. Now, some of you guys were actually solving for x and saying x is equal to something. And then I saw your factoring was correct. I circled it and I gave it to you. All right, but make sure you understand what they're asking you to do. Okay, they're only asking you to factor it. They're not asking you to solve for x. Everybody understand that? Okay. Same thing with here. It just says to factor. Because we haven't even done that lesson yet, right? We didn't do that lesson until 6-7 where we actually solve for x. All right. Try some numbers, right? The P over Q thing, plus or minus 1, 2, 3, 6, right? We don't need to list them all out. You know the early ones are probably going to work anyway. And 1 actually works, all right? So if I put a 1 in for this, let's see, that's 1 cubed is 1. That's a 1 that's minus 6. That's a plus 11, and that's minus 6. Does that work? Yep, that's negative 5. That's a 5. That is 0. So yes, that does work. All right, so what does that mean? That means that x minus 1 is one of my factors. Now let's do the division and find out, okay, what's left over. So I'm going to put a 1 right here and then take the coefficients. So that's going to be a 1, a negative 6, an 11, and a negative 6. Again, I don't have to fill in with any zeros because it goes in order, x cubed, x squared, x. All right, so I'm good to go there. Bring down the 1. 1 times 1, negative 5, 6, 6, 0. So what do I got? I got x minus 1 times, this was x cubed, so what's this going to be? X squared minus 5x plus 6. I made this pretty easy because this factor's really nice, so I got x minus 1. And then what's this going to be? 3 and 2, right? We'll give you negative 5, negative 3, negative 2. Is that right? Oops, forgot the x. So x minus 3, x minus 2, and you're good to go. Yep, doesn't matter what order you put it in. Doesn't make any difference. You just leave it. It does look better. I think I did it. No, I left it just like this, actually. But you could have... It doesn't matter. It does not make any difference whatsoever. There's no... Okay. If it makes it look better for you, switch the minus 3 and minus 2, and it'll look a lot better, and you'll be happy. All right. Is that helpful? And then obviously, section 6-7 was basically this, except what they do? They set it equal to 0. So if they did set it equal to 0, then what's x equal to? It's equal to 1, 3, and 2, or 1, 2, and 3 to make Hunter happy. All right? If it was set equal to 0. This one was not, okay? So I'm not looking at this for an answer. I'm looking at this for an answer, okay? Difference of 2 cubes. Did we do one of the? Oh, yeah, we didn't do that. All right, let's just do a basic one. Remember what we do? We go like this. Make this one a little bit bigger. I do the signs first. Same what? Opposite positive. So what's the same sign? Negative. And then this is opposite. This one's always going to be positive. Right? This is your A and B. All right? What's being cubed to give you y cubed? A y. And what's being cubed to give you 27? 3 is being cubed, isn't it? All right, so that's going to be a 3. What do we do here? Take that y and square it. I go to the last one. I take that 3, and what do I do? Square that. That gives me 9. And then I take the a and the b and just multiply them together. So what's that? 3y. Bang, you're done. And that's all there is to it. Okay? You got to know the pattern, all right? But if you know the pattern, it's not difficult to do. Would you agree? Okay. This one right here is a grouping, right? Because these are special factoring patterns. So this is a grouping. Yep. Grouping right there. Yep. We good? All right. This one was way easier than 10 because they kind of told you what to divide, didn't they? So if it's x minus 1, what are we putting in that little box? We're putting in a 1. That's right. Not a negative 1. We're putting in a 1. All right? And then that would be what? 3, 7, negative 2, 6. You can do the rest, right? Same thing right here. What are you putting in the little box? You're putting in a negative 1 on this one and then doing all that. All right. Did we pretty much cover everything? Did a long division. Well, we did synthetic division already. Long division. We didn't do that one, but almost everybody got that right. So everybody should be good with that. Everybody ready then? All right. Let's take it tomorrow. Now I got to stay up all night and make up the test, but I'll have it ready. I always do, don't I?
Most of the time. You don't have to have it ready.
I think I always do.
No, one time you're
I don't think I ever put off a day when I said we're going to take a quiz and say I didn't make it up.
I don't know, but you were late.
What, like 10 seconds?
Well, you say you also have the time on. You were late.
What I'm saying is, if I told you you're going to have a quiz a certain day or a test a certain day, I always have it made up for you.
You missed it then.
Never.
Oh yeah, geometry.
No.
No, in geometry. Geometry.
Maybe in geometry. Not this year, though. I haven't missed this year. I've been pretty good. I doubt it. All right. Anyway, be ready for it. And then that's it.